So in this video, I'm going to be working through Edexcel's AS Maths 2023 paper 1. So that is the pure paper. And I've got my numworks at the ready. So let's crack on. So this is question number 1. A curve has equation y equals 2/3 x cubed, take away 7/2 x squared, take away 4x plus 5. Part A, find dy by dx, writing your answer in simplest form. Okay, so dy by dx is equal to, so the power comes down to the front and we take 1 from the power. So you can leave the 2/3 there first if you like, and then differentiate the x cubed to make 3x squared, and then take away 7/2, and then the x squared differentiates to 2x, and the minus 4x differentiates to minus 4, and the plus 5 differentiates to 0. And then simplify this. So 2/3 times 3 is 2, so 2x squared. Then we're going to have 7/2 times 2, so 7x, then take away 4. And so there's dy by dx. Part B, hence find the range of values of x for which y is decreasing. So the curve will be decreasing when dy by dx is negative. So 2x squared, take away 7x, take away 4 is less than 0, and we need to solve this quadratic inequality. So what I'm going to do is I'm going to factorize the quadratic. I'm going to plug the quadratic into my solver. So 2x squared, take away 7x, take away 4. And we get minus 1/2 and 4. So if x is minus 1/2, one of the brackets will be 2x plus 1. And if we've got 4, then we've got x take away 4. Okay, so we have a quadratic. Here is the quadratic, the parabola, and it is crossing through at minus 1/2 and 4 on the x-axis. So where is the graph, the curve, below the x-axis? It's below it here. Okay, that is where the graph is below. So we are between minus 1/2 and 4. So minus 1/2 is less than x, is less than 4, is our answer. Or alternatively, we could write it in interval notation, which would be x belongs to minus 1/2, comma, 4 with curved brackets. So this is question number 2. Big bold writing at the start. In this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable. Using the substitution u is equal to the square root of x or otherwise, solve 6x plus 7 times the square root of x, take away 20 equals 0. So you'll notice that within the equation we've got both x and the square root of x. So if we're saying that u is equal to the square root of x, we can square both sides and then say, well, u squared must therefore be x. So we can replace the x with u squared, the square root of x with u. So therefore, 6u squared plus 7u, take away 20 is 0. So let's try and factorize this. So I'm going to plug that quadratic into my quadratic solver. 6x squared plus 7x, take away 20. And we get minus 5/2 and 4/3. So if minus 5/2 is a solution, then 2u plus 5 must be one of the brackets. And if 4/3 is the solution, then 3u minus 4 must be one of the brackets. Okay, so u is equal to minus 5/2, or u is equal to 4/3. So now that we've got that, we can replace the u back with root x. So we've got root x is equal to minus 5/2, or root x is equal to 4/3. Now, there's a problem with one of these, and that is that root x cannot be equal to minus 5/2. Now, the reason for that is that when you are square rooting a number, So x here would obviously have to be greater than or equal to 0. When you're square rooting that, you're taking the positive square root. So there's no plus minus at the front. So the positive square root will just give you a positive number, not a negative number. So it can't be minus 5/2. So root x is always going to equal to 0. So root x cannot be equal to minus 5/2. So root x must be equal to 4/3. And then if we square both sides, that means that x must be 16/9. And that is the solution to the equation. So this is question number 3. We've got figure 1. Figure 1 is a sketch showing the position of 3 phone masts, A, B and C. The masts are identical and their bases are assumed to lie in the same horizontal plane. From mast C, mast A is 8.2 kilometers away on a bearing of 072 degrees. So from C to A, this is 8.2 kilometers. Let's try and write that. Yeah. And then mast B is 15.6 kilometers away on a bearing of 039 degrees. So that's 15.6. And so then we can work out the angle between them. So 72 take away 39 is 33. Okay. Part A, find the distance between masts A and B. So we want to find this distance here. Giving your answer in kilometres to 1 decimal place. So because we've got a triangle, we've got the 2 sides and a trapped angle in between, we're going to use the cosine rule. So that this is side A, this is side B, and this is side C. Okay, then we have that C squared is going to be A squared plus B squared minus 2AB cosine C. So we're interested in C, of course. So A is 15.6, B is 8.2. So 15.6 squared plus 8.2 squared. Take away 2 lots of 15.6 times 8.2. Cosine of the angle 33 degrees. So 15.6 squared plus 8.2 squared, take away 2 lots of 15.6 times 8.2 times cosine of 33 is 96.034519. So if we square root both sides, we get C as 9.7997, etc. So 9.8 kilometers to 1 decimal place. An engineer needs to travel from mast A to mast B. Part B, give a reason why the answer to part A is unlikely to be an accurate value for the distance the engineer travels. So remember, these distances are in kilometers. They're, quite far. So the engineer is travelling from A to B, right, which we've just worked out is 9.8 kilometres. So it's unlikely, and that's a straight line, right? It's unlikely that there will be a straight line route from A to B, okay, because it's likely he'll have to drive, and so there won't be a perfectly straight line from road from point A to point B. So, as the engineer must travel 9.8 kilometres, they are likely to be driving and it is unlikely that there will be a perfectly straight road from A to B. So this is question number 4. Part A, sketch the curve with equation y equals k over x, where x is not equal to 0, where k is a positive constant. Okay, so let's set up some axes. So y equals k over x. Well, 1 over x is a graph that will look like this. Okay, y equals k over x also looks like this. The k just stretches it parallel to the y-axis. I mean, you can look at it at a parallel stretch parallel to the x-axis, but because you're multiplying by k, feels right to be parallel to the y-axis. So it still maintains a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. Okay? So, part B, hence or otherwise solve 16 over x is less than or equal to 2. There's two ways of going through this. So, one way is to consider, well, if you're looking at y equals 2, then that is a horizontal line. And we're interested in working out, firstly, that point there. So if you consider 16 over x is equal to 2, then that gives you x is equal to 8. And that would be that point there. So the inequality is asking, where is this graph below or equal to this graph, y equals 2? And it's below here, okay, because that's where the curve is below the line, and it's below it here, okay? The curve is below the line there. So the solution to the inequality is the left-hand bit. Now remember, x can't be equal to 0, so x is less than 0, or the right-hand bit. So you get these two regions, two inequalities, so x is greater than or equal to 8. So that's the first method. The second method for solving an inequality like this is to multiply both sides, not by x, because if you multiply both sides by x, x could be positive or negative, and so that causes a problem with the inequality symbol. So you need to multiply both sides by something that you know is positive, and that would be x squared. So if you multiply both sides by x squared, you get 16x is less than or equal to 2x squared. Okay, let's move everything onto the right-hand side and then divide through by 2. And then factorize. And now we're considering a parabola that is crossing through the x-axis at 0 and 8. And you're looking at whether this curve is above 0. So it's above it here and here. Now, because you can't have x being equal to 0, that implies that x is less than 0, only and not equal to 0, or the other region, x is greater than or equal to 8, which is the answer that we got before. Personally, I think it's better to go about it this way, because then you're using the graph that you've got, and then you can visualize where the inequality is coming from. So this is question number 5. Again, big bold writing. In this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable. So we have figure 2. The finite region R, shown shaded in figure 2, is bounded by the curve with equation y equals 4x squared plus 3, the y-axis, and the line with equation y equals 23. Show that the exact area of R is k root 5, where k is a rational constant to be found. Okay, this is the way I'm going to go about this. I'm going to consider this rectangle and then subtract the area underneath the curve, and that will leave me with R. In order to do that, I need to work out this point here, the x value that corresponds with the y value of 23. So I'm going to substitute y is 23 into the equation of the curve. I'm going to get 4x squared is 20. So x squared is equal to 5. So x is equal to plus or minus root 5. So this is positive root 5. So the region R is equal to the area of the rectangle, which is base times height, so 23 root 5. Then take away the integral between 0 and root 5 of 4x squared plus 3 dx. That's the area under the curve. So we have 23 root 5 take away. Now integrating 4x squared, we're going to add 1 to the power, divide by the new power. 3 integrates to 3x. And of course, because it's a definite integral, we don't need to worry about a constant of integration. And we're evaluating between 0 and log 5. Sorry, 0 and root 5. Okay, so we have 23 root 5, take away. Now substituting the root 5. So we've got 4/3 times root 5 cubed. Now root 5 cubed, root 5 times root 5 times root 5 is 5 root 5. Multiply that by 4/3, we've got 20/3 root 5. Then we have 3 lots of root 5, so 3 root 5. Then substituting 0, we get 0 plus 0. So we have 23 root 5 take away. 20/3 plus 3 is 29/3. So 23 take away 29/3 is 40/3. So 40/3 root 5. So k is 40 over 3. And that's the rational constant that we needed to find. So this is question number 6. The circle C has equation x squared plus y squared take away 6x plus 10y plus k equals 0, where k is a constant. Part A. Find the coordinates of the centre of C. So let's rewrite it. So we've bundled the x's together and the y's together. And we're going to use completing the square here. So complete the square on the x's. We're going to have x take away 3 squared, then take away the 3 squared, so take away 9. And then y plus 5 squared, take away 5 squared, is take away 25, plus k equals 0. So we can rewrite that in this form. So minus 9 take away 25 is minus 34. So we're going to have 34 take away k on the right hand side. So the centre C can be read off as 3 minus 5. Part B. Given that C does not cut or touch the x-axis, find the range of possible values for k. So let's just draw a quick little sketch of what's going on here. So we have a circle centred at 3 minus 5. So 3 along, 5 down, somewhere about there. And then your circle is doing something like that. So that distance is your radius. Now, if this point was at 3 minus 5, then you don't want the radius to be any longer than 5. You don't want it to be equal to 5, you want it to be less than 5, right? So the radius must be less than 5. And also we need a positive radius, right? You can't have a radius of 0. So we also need the radius to be greater than 0. Now, the 34 take away k that we have here, remember that is r squared, that's the radius squared. So 34 take away k must be less than 5 squared, so less than 25. So that implies, if you add k to both sides, take 25 from both sides, that k must be greater than 34 take away 25 is 9. So k is got to be greater than 9. And the 34 take away k is also got to be positive, so greater than 0 squared. So that means that k must be less than 34. So therefore, combining those two inequalities, we must have that k is greater than 9 but less than 34. So this is question number 7. The distance a particular car can travel in a journey starting with a full tank of fuel was investigated. From a full tank of fuel, 40 litres remained in the car's fuel tank after the car had travelled 80 kilometres. From a full tank of fuel, 25 litres remained in the car's fuel tank after the car had travelled 200 kilometres. Using a linear model, with V litres being the volume of fuel remaining in the car's fuel tank and D kilometres being the distance the car had travelled, part A, find an equation linking V with D. I think it would probably be a good idea to draw a little graph here. So let's visualise what's going on. So we're going to have V as the volume of fuel remaining in the tank against D, the distance travelled. So 40 litres travelled 80 kilometres. So 80/40 is one of the points. So 80 kilometres, 40 litres. And the other one is 200 kilometres, 25 litres. So somewhere down here, 225. And we're going to use a linear model, so a straight line graph joining the two. Okay, so part A, we need to find the equation that does that. So if we use y minus y1 equals mx minus x1, so let's use 80/40 as x1, y1. So y, or v in this case, minus y1, which is 40, is equal to m, so the gradient of that line, so we need the difference in the y coordinates divided by the difference in the x coordinates. And then we've got x take away x1, so in this case d take away 80. Okay, so let's substitute or put 40 take away 25 over 80 take away 200 into the calculator, and we get minus 1/8. So we'll have minus 1/8 d. That's going to multiply with the minus 80, multiplying out the bracket. That gets us 10, and then we add the 40 to both sides, so that gets us plus 50. And there's my equation. Given that on a particular journey, the fuel tank of the car was initially full, the car continued until it ran out of fuel, find, according to the model, B part 1, the initial volume of fuel that was in the fuel tank of the car. So initially the car has travelled a distance of 0. So when D is 0, V is going to be minus 1/8 times 0 plus 50. So 50, and that's litres. So there was 50 litres initially in the car. Part 2, the distance that the car travelled on this journey. Well, that will be when it has completely depleted the fuel reserve, which will be when V is 0. So 0 is equal to minus 1/8 d plus 50. So if we add 1/8 d to both sides, multiply through by 8, we get that d would have to be 400. So that's 400 kilometres. Okay. In fact, the car travelled 320 kilometres on this journey. Part C. Evaluate the model in light of this information. Well, the model suggests that we'll travel 400 kilometres, but we actually travelled 320 kilometres. So the model appears weak, as 320 kilometres is much less than the predicted 400 kilometres. So the model does not appear appropriate, or to be appropriate. Okay, so this is question number 8. We've got figure 3. Figure 3 shows a sketch of a curve C and a straight line L. Given that C has equation y equals f of x, where f of x is a quadratic expression in x, C cuts the x-axis at 0 and 6, L cuts the y-axis at 60, and intersects C at the point 10, 80. Use inequalities to define the region R, shown shaded in figure 3. Okay, let's concentrate on L first. So we need to find the equation of the line L. We know that it goes through 60, we know it goes through 1080. So L has the equation of y equals, now the gradient, so that would be 80 take away 60 over 10 take away 0, difference in y over difference in x, times x, and we know that it goes through 60 on the y-axis. Okay, so the line has the equation y equals 20 over 10, so 2x plus 60. Now, because we are looking at the region below the line, we must have that y is less than or equal to 2x plus 60. So that's our first inequality. Now we need to find the equation of the curve C. Now, this is a parabola that is going through 0 and 6. So we can write it in factorised form, 0 and 6 on the x-axis, but we don't know if there is a multiplier at the front. So it must be of the form of k x take away 6. So the x take away 6 is the factorised form. The k dealing with the fact that we don't know how stretched out the curve is. But we do know it goes through 1080. So I can substitute 1080 into the equation. So 10 take away 6 is 4. So k must be equal to 2. So therefore we have y is equal to 2x, x take away 6. And the region we're looking at is the region above the curve. So therefore, y must be greater than or equal to 2x, x take away 6. So we now have these two inequalities that we can bring together in one. So y must be greater than or equal to 2x, x take away 6, but less than or equal to 2x plus 60. And that's my answer. So this is question number 9. Using the laws of logarithms, solve the equation. 2 log base 5 of 3x take away 2, take away log base 5 of x is equal to 2. So let's bring the 2 up to the power first. So log base 5 of 3x take away 2 squared. So use the power rule first. Take away log base 5 of x is equal to 2. So now let's use the quotient rule. So we have log base 5 of 3x take away 2 squared over x is equal to 2. So now let's convert the logarithm into exponential form. So we have 3x take away 2 squared over x is going to be equal to 5 to the power of 2. So 5 squared, which is 25. Multiply both sides by x. So 3x take away 2 all squared is equal to 25x. Let's expand out the brackets. So 9x squared take away 12x plus 4 is 25x. Okay, let's take away 25x from both sides. So take away 37x plus 4 is 0. Right, so I'm going to plug that into my quadratic solver. So 9x squared take away 37x plus 4. And that gets me 1/9 and 4. So that means that our brackets will be 9x take away 1 and 4, so x take away 4 is 0. So that gives us x is 1/9 or x is equal to 4. Now, as is the way with these types of questions, sometimes only one of those answers works. So if we look at x is 4, log base 5 of 3 lots of 4 take away 2 is log base 5 of 10, that's fine. Log base 5 of 4 is fine. But it's when we substitute in 1/9, that's where we're going to have a problem. So log base 5 of 3 lots of 1/9 take away 2 is, so we have 3/9 take away 2 is minus 5/3. So we're trying to substitute a negative number into the original equation, and that causes a problem. Is not real. So the only solution to the original equation is x is equal to 4. So this is question number 10. We have figure 4. The line L1 has equation y equals 3/5 x plus 6. The line L2 is perpendicular to L1 and passes through the point B, 80, as shown in the sketch in figure 4. Part A. Show that an equation for line L2 is 5x plus 3y equals 40. So we know that it goes through 80. We know that it's got to be perpendicular to y equals 3/5 x plus 6. So for part A, using y minus y1 equals mx minus x1, y minus 0 is equal to the negative reciprocal of 3/5, so minus 5/3. X take away x1, which is 8. So let's multiply through by 3, and we're going to get 3y is equal to, multiply through the bracket by minus 5, minus 5x plus 40, and then add the 5x to both sides, and we get 5x plus 3y is equal to 40 as required. Given that lines L1 and L2 intersect at the point C, line L1 crosses the x-axis at the point A. Part B, find the exact area of triangle ABC, giving your answer as a fully simplified fraction in the form P over Q. So we need to find the area of this triangle in here. Okay, so what I intend to do is work out where the two lines intersect. So I work out the coordinates of C. I then know what the perpendicular height is of the triangle. And if I know where A is and I know where B is, then I can also work out the base. Okay? Now we know that B is at 8. So 8, 0. So I've got that information already. So I just need to find the coordinates of C and the coordinates of A. So the line L1 has the equation y equals 3/5 x plus 6. Let's rearrange it. Multiply both sides by 5. And then rearrange that to get minus 3x plus 5y is equal to 30. So let's use these two equations and find where that intersection is. So I'm going to do that by plugging them both into my calculator, into the simultaneous equation solver. So 5x plus 3y is equal to 40, and minus 3x plus 5y is equal to 30. So we get 55 over 17 and 135 over 17. So the lines intersect here. Okay, so I now know the coordinates of C. Now I just need to find the coordinates of A. So, in order to do that, I need to find out where line L1 intersects the x-axis. So, L1 intersects x-axis when y is 0. So if I put y is equal to 0, I'm going to have minus 3x is equal to 30, so x is minus 10. Okay, so my triangle looks something like this, where this distance, the vertical distance, is 135 over 17, and this distance here, remember, is going from 8, and that's minus 10, and so that distance is going to be 18. So the area of the triangle is 1/2 times by the base times by the perpendicular height, which is 135 over 17. So 1/2 times 18 times 135 over 17 is 1,215 over 17. And that's in the format we want. So this is question number 11. The height, h meters, of a plant, t years after it was first measured, is modelled by the equation h equals 2.3, take away 1.7 e to the minus 0.2t, where t is a real number and t is greater than or equal to 0. Using the model, part A, find the height of the plant when it was first measured. Okay, so we want to substitute t is 0 into our height equation. So 2.3 take away 1.7 e to the minus 0.2 times 0. Now e to the 0 is of course 1, so 2.3 take away 1.7 is 0.6, and that was in meters, so 0.6 meters. Part B. Show that exactly 4 years after it was first measured, the plant was growing at approximately 15.3 centimetres per year. Now that is a rate, okay? So that needs dH by dt. So we need to differentiate h with respect to t. The 2.3 differentiates to 0, so that's gone. The e to the minus 0.2t, what happens is that the coefficient of t, minus 0.2t, minus 0.2 rather, just that bit, comes down to the front. So we'll have minus 1.7, which is the multiplier, times by minus 0.2 coming down to the front, and e to the minus 0.2 stays as it is. You don't take 1 from the power or anything like that, okay? Exponentials differentiate in that way. So, what have we got there? So, we have 1.7 times 0.2, and that's 0.34. So we'll have 0.34 e to the minus 0.2t. So we want to show that exactly 4 years after it was first measured. So we want to substitute t is 4 into this. So we get 0.34 times e to the power of minus 0.2 times 4, which is 0.152771, etc. Now that is in meters, so that's meters per year. And to convert that into centimeters, we multiply through by 100, so that's 15.2771 centimeters per year, which is 15.3 centimeters per year to 1 decimal place. Okay. Part C. According to the model, there is a limit to the height to which this plant can grow. Deduce the value of this limit. Okay, so here was my equation again. H equals 2.3, take away 1.7 e to the minus 0.2t. So, as t tends to infinity and gets larger, e to the minus 0.2t gets smaller and smaller and smaller. So h tends towards 2.3. Okay, so the maximum height is 2.3 meters, and that's my answer. So this is question number 12. In this question, you must show detailed reasoning. Solutions relying entirely on calculator technology are not acceptable. So, part A. Show that the equation 4 tan x equals 5 cosine x can be written as 5 sine squared x plus 4 sine x, take away 5 equals 0. Okay, so first of all, the tan x can be replaced with sine x over cosine x. We can then multiply both sides by cosine x. So we'll get 4 sine x is equal to 5 cosine squared x. Now cosine squared can be replaced with 1 minus sine squared. So 4 sine x is equal to, and don't forget the bracket, 1 take away sine squared x. Now let's expand that bracket. And then move everything onto the left-hand side. Okay, as required. So, part B. Hence, solve for 0 is less than x is less than or equal to 360 degrees. 4 tan x equals 5 cosine x, giving your answers to 1 decimal place. So we need to solve this quadratic. So the hence part is that we're going to use the result that we got from part A. So this is a quadratic that we can factorise. Well, maybe factorise, say. Let's see what we get. So we're going to plug it into the quadratic solver. I always anticipate it's going to factorise, but that might not always be the case. So 5x squared plus 4x take away 5, so it's a hidden quadratic. It doesn't factorise. There you go. So we get sine x is equal to, so minus 2 plus or minus the square root of 29 all over 5. Okay, so let's work out what the decimalised versions of those are. So if it's the subtraction, it's equal to minus 1.47703, etc. Or if it's the plus, we've got 0.67703, etc. Now, we can't have sine x is minus 1.477 because sine x goes between minus 1 and 1. So minus 1.477 would be strictly underneath the curve. So think of it like this. Here's your curve, and the lowest point is at minus 1, and minus 1.477 is a line going far underneath it. Okay, so we can't have that. So sine x cannot be equal to minus 2 take away root 29 over 5, as minus 2 take away root 29 over 5 is less than negative 1. Okay, so sine x is equal to minus 2 plus root 29 over 5. So if we inverse sine that, so arc sine of minus 2 plus root 29 over 5, we get 42.6 degrees, so 42.61222. Now, the sine curve looking like this. Okay, so here's your minus 2 plus root 29 over 5, so this is the 0.677. And you can see it's crossing through the curve in two places. So if that is 42.6, then that is 42.6, given that that's 180. So I can get the second solution by subtracting from 180, and we get 137.4 to one decimal place. Okay, so part C. Hence find the number of solutions in bold of the equation 4 tan 3x equals 5 cosine 3x in the interval 0 to 1800 degrees, explaining briefly the reason for your answer. So 4 tan x equals 5 cosine x has two solutions between 0 and 360. Okay, so 4 tan 3x equals 5 cosine 3x. If you replace the x with 3x, that stretches the graph by factor a third, parallel to the x-axis. So what that means is that you have 3 lots of 2 solutions between 0 and 360. So that has 3 lots of 2, so 6 solutions between 0 and 360. Okay, and then you're going from 0 to 360, and then 360 to 720 and so on, all the way up to 1800 degrees. So that's going to be 5 lots. 5 lots of 360 gets you to 1800. So 4 tan 3x equals 5 cosine 3x has 5 times 3 times 2, so that would be 30 solutions between 0 and 1800 degrees. And thank goodness we don't have to find them all. So this is question number 13. Relative to a fixed origin O, point A has position vector 10i minus 3j, point B has position vector minus 8i plus 9j, point C has position vector minus 2i plus pj, where p is a constant. So part A, find AB. So the vector A to B Well, that will be OB minus OA. So OB is minus 8I plus 9j. And we're going to take away OA, so 10I, take away 3j. So minus 8 take away 10, that's minus 18I. And then 9 take away minus 3 is plus 12j. And so that's AB. Part B, find the modulus of AB, so the length of AB, giving your answer as a fully simplified surd. So the length of AB is the square root of minus 18 squared plus 12 squared. So using Pythagoras' theorem, so we have minus 18 squared plus 12 squared is 468. So square root of that is 6 root 13. Okay. Given that points A, B and C lie on a straight line, part 1 of C, find the value of P. Okay, so if they all lie on a straight line, then AB and AC must be parallel. Okay, so think of it like you've got these 3 points that lie on the line. So let's say that's your A, B and C. So AB and AC, these must be parallel, right? So AB and then AC. So we're going to use that fact. So we've already got AB. So if we work out AC, so AC is OC minus OA. So minus 2I plus PJ, take away 10I minus 3j. So we're going to get minus 2 take away 10, so minus 12I, and then P take away minus 3, so P plus 3j. So these two vectors, AB and AC, must be parallel, so AB is equal to some multiple of AC as parallel. So that means that minus 18, the component, the I component of AB, must be equal to K times the I component of AC, so that's minus 12K. So if we do minus 18 divided by minus 12, that's going to be 3 halves. So K is 3 halves. So then the J component of AB must be 3 halves times the J component of AC. So if I do 12 divided by 3 halves, that's 8. Take away 3 is 5. So P is 5. Part 2, state the ratio of the area of triangle AOC to the area of triangle AOB. I think it would probably be worth us drawing a little diagram. Okay, so we've got our 3 points. So A is 10I minus 3j, so somewhere down here. So let's say that's A. This only needs to be rough, okay? So there's A. B is minus 8 plus 9, so it's somewhere up here. So there's B. And then C is minus 2 plus 5. So, and they've all got to be on the same line, remember. So C's got to be somewhere here. And here's O at the origin. So we are considering the area of triangle AOC which is that one there, to the triangle AOB. Okay, so you can see that triangle AOB is larger than triangle AOC. And we know from getting the K as 3 halves that AB is 3 halves times AC. So you've got AC here. AB is 3 halves times the length. So that means, because they'll both have the same perpendicular height, you're just stretching it along the axis. One will be 3 halves larger than the other. So triangle AOB is 3 halves times the area of AOC. So area of AOB equals 3 halves times the area of AOC. Okay, so that means that the ratio is 1 to 3 halves, or you can multiply both sides by 2, and so it's 2 to 3. So this is question number 14. Find in simplest form the coefficient of x to the 5 in the expansion of 5 plus 8x squared times 3 take away 1/2 x to the 6. Now, the 5 plus 8x squared, that's it. We don't need to do anything with that. The 3 take away 1/2 x to the 6. Now that's going to have a constant term. It's going to have a linear term. So something x, you can have a quadratic term, something x squared, a cubic term, quartic term, x to the 5, x to the 6. Okay? The ways that we can multiply those two brackets together to get an x to the 5 is from multiplying the 5 with the x to the 5 term in the binomial expansion. So that's one way of doing it. So that's 3 pieces. So the x to the 5 term will have 3 in the middle and minus 1/2 x there. Okay. Now because you want to the power of 5, that's got to be a 5. So the power of 3 has got to be 1, because those two powers have got to add up to 6. And the first bit is Pascal's triangle, which is either 6 choose 1 or 6 choose 5. They're both the same because Pascal's triangle is symmetric. So that's the first way. Or the 8x squared could multiply with the cubic term to make an x to the 5. So the 8x squared could multiply with the cubic term. So the middle and the final box are the same. Because we want the cubic term, this has got to be 3. So that means the power of 3 has got to be 3, because they've got to add up to 6 again. And then the first box is Pascal's triangle, which is 6 choose 3. Okay. So we have 5 times 6 choose 5, which is 6, right? So 6 NCR 5 is 6. 3 to the 1 is 3, times by minus 1/2 to the 5, which is minus 1 over 32, x to the 5. Then we have 8 times by 6 choose 3, which is 20, times by 3 cubed, which is 27, times by minus 1/2 cubed, which is minus 1/8, and that's going to be x to the 5, because you've got the x squared times the x cubed, right? Okay, so we have 5 times 6 times 3, times minus 1 over 32, which is minus 45 over 16, x to the 5. And then we've got 8 times 20 times 27 times minus 1 over 8, which is minus 540, x to the 5. So minus 45 over 16 take away 540 is minus 8685 over 16, and that's x to the 5. So remember, the question's just asking for the coefficient, so the coefficient is minus 8685 over 16. This is question number 15, and in bold, in this question you must show detailed reasoning. Solutions relying on calculator technology are not acceptable. The curve C1 has equation y equals 8 take away 10x plus 6x squared take away x cubed. The curve C2 has equation y equals x squared take away 12x plus 14. Part A. Verify that when x equals 1, the curves C1 and C2 intersect. So I need to substitute x equals 1 into the two curves. So for C1, substituting x is 1, we're going to get 8 take away 10 plus 6 take away 1. So 8 take away 10 is minus 2, plus 6 is 4, take away 1 is 3. So for the second curve, substituting in x is 1, we get 1 squared, which is 1, take away 12 lots of 1, plus 14. So 1 take away 12 is minus 11, plus 14 is 3. So they're consistent. So C1 and C2, oops daisy, let's try and write that again, and C2 intersect at 1, 3. The curves also intersect when x equals k. Given that k is less than 0, part B, use algebra to find the exact value of k. Right, so I'm going to try and do this without calculator then. Let's just go straight in. So if we're looking for intersections, we need to put the two equations equal to one another. So put one equation equal to the other. So then we want to rearrange this equation, get everything onto one side. I'm going to put everything onto the right-hand side. So 0 equals, we're going to have x cubed. We're going to take 6x squared from both sides, so minus 5x squared. We're going to add 10x to both sides, so take away 2x. And we're going to take 8 from both sides, so plus 6. Okay? Now, I want to factorise this. I know that x equals 1 was a solution, so was a root. So x take away 1 is a factor, which means I should be able to factorise this, bringing x take away 1 outside. So I'm going to use polynomial division to do that. You can do this by inspection as well, and I'm going to use the grid method. So x take away 1. So I need x cubed, so there's a multiplication grid, and the only way I get x cubed is if I'm multiplying x with x squared. So x squared times minus 1 is minus x squared. But I don't want minus x squared, I want minus 5x squared, so I'm going to need another minus 4x squared. So x is into that go minus 4x. Minus 4x times minus 1 is 4x. But I don't want 4x. I want minus 2x, so I'm going to have to take 6x away. So that would be minus 6, and minus 6 times minus 1 is 6. And 6 is just what I want, so there's no remainder. So I can then say that the cubic is x take away 1 times by what appears at the top here, x squared take away 4x take away 6. Okay, so either x equals 1 or x squared take away 4x take away 6 is 0. Now, k can't be 1 because k is negative, so I can ignore the x equals 1 solution now. So if I solve this quadratic, I'm going to complete the square, because I don't think it factorises. So x take away 2 squared, take away 2 squared, take away 6, So we're going to have equals 10. So x is going to be equal to 2 plus or minus the square root of 10. But as k is less than 0, we must have the negative one of that. So k equals 2 take away root 10. And that's my answer. So this is question number 16. A curve has equation y equals f of x, where x is greater than or equal to 0. Given that f prime of x, so the first derivative of f, is 4x plus a times the square root of x plus b, where a and b are constants. The curve has a stationary point at 4, 3, and the curve meets the y-axis at minus 5. Find f of x, giving your answer in simplest form. So we know that stationary points exist. When f prime of x is 0. So we know that f prime of 4 is 0 because we know that there's a stationary point of 4, 3. So if I substitute 4 into f prime, so 4 lots of 4 plus a times the square root of 4 plus b, this has got to be equal to 0. So let's tidy this up, because the square root of 4 is 2, so that's going to be 2 lots of a plus b, and let's move the 4 times 4 over to the other side, so we'll have minus 16. So I'm going to label that as equation 1 because this looks like a simultaneous equation problem. Okay, now we know that the curve goes through 4, 3, and we know that it goes through the y-axis at minus 5. So if we integrate the curve, so first of all, let's rewrite the equation, the first derivative rather, as 4x plus a times the x to the half plus b, and now we're going to integrate. So add 1 to the power, divide by the new power, add 1 to the power, we get 3 halves, divide by the new power, we get 2/3 at the front, ax to the 3 halves, so 1 over 3 halves is 2/3, and b integrates to bx, and we're going to have a constant of integration plus c. Now, we know that the curve meets the y-axis of minus 5, so when x is 0, y is equal to minus 5, so minus 5 is equal to 4 times 0 squared over 2, so 0 plus 0 plus 0 plus c. So c is clearly negative 5. So we've got f of x is 2x squared plus 2/3 ax to the 3 halves plus bx, take away 5. Now, we still know that the curve goes through 4, 3. So, seeing as f of 4 is 3, we can substitute 4 in, and we're going to get 2 lots of 4 squared plus 2/3 a times 4 to the 3 halves plus b times 4, take away 5 is equal to 3. So if we tidy this up, we have 2/3 times 4 to the 3 halves. Let's deal with that first. That's 16/3 a plus 4b. Then 2 lots of 4 squared. Take away 5 is 27. Take it over to the other side, so 3 take away 27 is minus 24. And there we have a second equation. So we now have 2 equations with 2 unknowns. So A equals and B equals. So now we're going to put those into the equation solver, so simultaneous equation solver. 2a plus b is equal to minus 16. And 16 thirds times A plus 4 lots of B is equal to minus 24. And we get A is minus 15 and B is 14. So we want to find f of x. So we need to finish by writing f of x equal to 2x squared plus 2 thirds times a x to 3 halves. So 2 thirds times minus 15 is minus 10. And then we've got b lots of x, so plus 14x, take away 5. And that's my answer. So this is question number 17. In this question, p and q are positive integers with q greater than p. Statement 1. Q cubed take away p cubed is never a multiple of 5. Part A, show by means of a counterexample that statement 1 is not true. So, essentially we just need to choose a q and p that fit, that q is greater than p, and show that that's a multiple of 5. So it makes sense in my head to choose two numbers that are both multiples of 5 already, right? So if we let q be 10 and p is 5, then q is clearly greater than p, right? So that's satisfied. Q cubed take away p cubed will be 10 cubed take away 5 cubed. So 10 cubed take away 5 cubed is 875, which is a multiple of 5. Okay? Part B. Statement 2, when p and q are consecutive even integers, q cubed take away p cubed is a multiple of 8. Prove, using algebra, that statement 2 is true. Okay, so consecutive even numbers. So p can be 2n, and q can be the next even number along, 2n plus 2, where n is a positive integer. Okay? Then what we could do is, because q cubed take away p cubed will be 2n plus 2 cubed take away 2n cubed. So we need to work out 2n plus 2 cubed. Now you can do that a longer way if you like, expand out triple brackets, or you can use binomial expansion. So I'm going to use binomial expansion. We're going to have 2n all cubed, so 2n all cubed, plus, so 3 choose 1, so 3, times 2n squared times 2, plus 3 choose 2, so 3, times 2n to the 1 times 2 squared, plus 2 cubed, and then we're going to take away 2n all cubed, which is 8n cubed. So that's 8n cubed. Then we've got 3 times 4 times 2, so 24 n squared. Then we've got 3 times 2 times 2 squared, which is 24 n. Then we've got to take away, so we've got the plus 8 rather, and then we've got to take away 8n cubed on the end. So the 8n cubes cancel away. We're going to get left with 24n squared plus 24n plus 8. And we can factor the 8 out of that. Oh, sorry, not 24n squared anymore, is it? That'll be 3n squared plus 3n plus 1. Apologies. Okay, and so now we have that is a multiple of 8, which is a multiple of 8. Okay, and we're done.